chamber is attached to the caliper housing and operates directly onto the internal components of the caliper housing. The caliper slides freely on the sealed carrier support pins and provides even force on the inner and outer pads, providing a structure capable of very high clamping loads that are needed for high-performance stopping. The internal components of the caliper, actuation system, and automatic adjuster are permanently lubricated to minimize the maintenance requirements. In general, the brake operates as follows. The air chamber push rod is in constant contact with the internal operating shaft of the caliper. Seals in the caliper housing and chamber assemblies provide sealing between the air chamber and housing. The carrier is mounted to the torque plate, and the torque plate to the vehicle axle. The carrier straddles the rotor and supports the brake pads. The caliper incorporates two pistons that mechanically push the inner pad into the rotor. The housing assembly slides on two fully sealed slide pins, which are bolted to the brake carrier. As the housing slides inward, the bridge pulls the outer pad into the rotor, thus the name sliding caliper brake. As the pads wear, adjustment takes place automatically and independently of load. Load independent means adjustment takes place under very small clamping forces only, therefore preventing over-adjustment and minimizing air consumption. Now let's take a look at the operation of the EX Plus air disc brake in more detail. When the operator applies the vehicle brake, air from the air chamber applies force to the chamber push rod. Then the push rod moves the operating shaft of the caliper. The force introduced from the air chamber is amplified by the geometry of the operating shaft. The operating shaft moves inward, transferring this force to the inboard pad through the half bearings, rollers, tappets, pistons, and piston heads of the caliper assembly. The twin-bearing lever mechanism provides equal application pressure to each of the two pistons and then to the inner brake pad. As the operating shaft moves and the piston tappets push the pistons to apply the inner brake pad against the brake rotor, the entire caliper housing and bridge assembly move inward, causing the outer brake pad to be applied to the brake rotor. The caliper and bridge float or slide on the slide pins during brake application and release. The rate at which the vehicle slows down or stops depends on the amount of air pressure being applied from the air chamber. When the vehicle operator releases the foot brake, the return spring in the air chamber retracts the push rod. The return spring in the caliper assembly pushes the pistons back to their at-rest position. Additionally, the retraction of the pistons by the caliper return spring keeps the air chamber push rod in contact with the operating shaft at all times, ready for the next brake application. Once the pistons are retracted during brake release, the small runout of the brake rotor and hub bearing clearances will then generate a small clearance for the pads through only a few revolutions of the rotor. The brake pads move away from the rotor with a defined running clearance to the rotor. The automatic adjuster adjusts the brake pad clearance to compensate for pad wear. Every time the brake is applied, the automatic adjuster system senses whether adjustment is required or whether the running clearance of the brake pads to the brake rotor is still within the built-in tolerance and does not need to be adjusted. The built-in tolerance is determined in the design by the clearance between the ball-ended drive pin that is rigidly fixed to the operating shaft and the fork on the end of the adjuster shaft. When the brake is applied, the drive pin actuates the fork on the adjuster shaft. When the clearance between the pad and the rotor is greater than the built-in tolerance level of the adjuster mechanism, the unidirectional friction spring and clutch pack lock and rotate the intermediate gear assembly. The intermediate gear assembly is in continuous contact with the piston tappet gears. As the intermediate gear rotates, the piston tappet gears rotate, which unscrew the pistons until the brake pad engages the rotor. Once torque increases from the pads contacting the rotor, the threads in the piston create a higher torque needed to continue rotating the tappets. When this occurs, the clutch assembly in the automatic adjuster slips and stops the adjustment process. This process occurs only when the driver applies the brake and adjustment is required. No adjustment is made when the brake is released. It's important to know that manual adjustment of the brake must be made only when service to the pads, rotor, or hub is required. No manual intervention is required between pad changes. The manual adjuster stem runs in constant mesh with the gear from on the outside of the tappets. The end of this stem comes out from the brake housing through a seal and is protected by an adjuster cover. The automatic adjuster maintains a nominal pad-to-rotor clearance of approximately 30/1000ths of an inch. Since the manual adjustment mechanism is in constant contact with the tappet gears, when automatic adjustment takes place, the 10mm hex of the manual adjuster moves also. As the automatic adjustment takes place, the manual adjuster moves in a clockwise direction. Now let's discuss how the manual wear indicator works during vehicle operation. When the brake pads are new, the caliper and bridge assembly is in the full lining thickness position. The manual indicator displays this. As the lining wears, the caliper and bridge move inward towards the center of the vehicle. Since the mechanical visual wear indicator and spring is mounted between the ridge carrier and the moving caliper assembly, wear of the brake pads and inner movement of the caliper allows the caliper to cover more and more of the indicator. Once the indicator shows more than 75% wear, the pads require further inspection or replacement. If the brake is equipped with the electronic pad wear indicator, lamps will illuminate, indicating the need for pad replacement per the following sequence: yellow, service required soon, and red, pad replacement required. During a preventive maintenance, the technician will visually inspect the manual wear indicator and, if equipped, the indicator lamps to determine if service is needed. More inspection information is covered in the EX Plus Preventive Maintenance course. This concludes the Meritor EX Plus Air Disc Brake Operation course. To receive credit for this course, you need to pass the course quiz. You need to score at least 90% on the quiz to pass. Select Next to begin the quiz.